Hello everyone. Good morning, good afternoon, good evening, depending upon where you are joining today. Welcome to Scottish Summit 2021. My name is Deepthi Goguri. Today we are going to talk about understanding the statistics in SQL Server. So this particular session is all about statistics. There is a lot of content to grab, so hopefully you like it. Let's get started. A big thank you and shout out to all of our sponsors, ScriptRunner, DQ Global, Driving Data Quality, Proximo 3, Redspire, Agilicis, and Hitachi Solutions for sponsoring Scottish Summit 2021. Without all of our sponsors, this event would not have been possible. Thank you so much. So, a little bit about me. I'm a database administrator having a lot of experience in managing SQL Server and databases. I'm a Microsoft certified trainer and Microsoft certified solution expert. I did my master's in computer technology at Eastern Illinois University. I do blog for dbanuggets.com. That's my website, and you can contact me on Twitter at dbanuggets. That's my user ID. Like if you want to get in touch with me, I'm always active on Twitter, so you can contact me on Twitter. So what are we going to discuss in this session today? We are going to talk what are statistics, how to view statistics, what happens when they are not accurate, and how to update the statistics and maintain the statistics. So statistics, what is it all about, right? Statistics are the blob structures which are saved inside the system tables to describe the distribution of the data inside a column or set of columns or an indexed view. The query optimizer inside the SQL Server will use and trust these statistics to determine how many rows it think gonna come back out of a table or a column, which is also known as cardinality estimates. So the accurate these estimates are, it will help the optimizer to generate good enough plans. So why should we care about these statistics, right? If our statistics are out of date, then that will cause the optimizer to generate a non-efficient plan to be saved inside the plan cache, and our queries will use that non-optimal plan to execute the queries, which will cause the slow query response times. The excessive resource utilization occurs, like the high CPU, memory, and I/O, because all of these physical access methods are based upon these estimates. So if the estimates are not accurate, then that will cause the inaccurate joins to be chosen in our execution plans. And if our estimates are way too low when compared with actuals, then the optimizer will only get some of the memory grants for the queries based upon those wrong estimates, low estimates, and while the query has to go to the execution phase, it has to actually spill to the tempdb, which is spills to the disk, right? And if at all in reverse it happens, like if the accurates are way too above when compared with actuals, then that will affect the concurrency because the memory grants that are released are way too above, way too high than they actually needs. So we are wasting the memory, we are reducing the throughput as well as the concurrency of the queries. So how the query optimizer will use these statistics? Optimizer will use the statistics to determine whether it have to use clustered index or non-clustered index, or whether it have to do seek or a scan on those indexes, what kind of like whether it requires the lookups, whether the lookups are needed, like what kind of join we have to use, like hash join, nested loop, or merge join, or whether the query have to go serial or parallel, or what kind of execution mode it use, whether to use the batch or row execution mode. All of these physical access methods, all of these operations are based upon the statistics. The accurate the statistics are, it will help the optimizer to make sure these operations are accurate as well, saving the optimal plan inside our plan cache. So what are the options for the statistics? In the database properties, we have especially four options for the statistics especially. The first option is auto create statistics. This particular option is turned on by default. The second option is auto update stats. Auto update stats is also turned on by default. So it is advisable to put auto create stats and auto update stats to be enabled, because that will help the SQL Server will go ahead and create the stats whenever it needs and update them. The third option is auto update stats asynchronously. This option is disabled by default. We are going to talk about this particular option, like when it is useful, in the coming slides. The fourth option is auto create incremental statistics. This particular option is especially for the partitioning. It is disabled by default. So if you have partitioning, then you can think about enabling this option. So there are many ways the statistics can get created. The first way is automatically, right? Whenever your auto create stats is turned on at the database level, SQL Server will go ahead and automatically create stats on every index you create, or like clustered index, non-clustered index, filtered index, or an indexed view. Let's go ahead and see with an example. Here I'm creating a non-clustered index on a territory ID column, and when I see the sys.stats view, I can clearly see a stats got created with the same exact name of the index on the same exact column, territory ID. But the name might be same, but the stats as well as the index are two different entities, right? The index will save the data itself, but the stats will just describe the distribution of the data at the time of the stats update. And stats can also automatically get created on single columns. It can get created when we are searching on a column or when we are joining on a column. Let's see an example. Here I run this particular query searching on the column color. When I first execute that query and search sys.stats view, I clearly see that there is a stat got created, a system generated stat got created on the color column. Now, how do we read this system generated stats, right? The underscore WA represents Washington State, underscore sys represents system, underscore 0006 represents the column ID inside a table, and 08B5, that number is a hexadecimal value of the table. And index statistics can also automatically created when we are joining on a column, right? So here in this example, we are joining on list price column. So once I run this query for the first time and then do the sys.stats view, I clearly see there is a system generated stats that got created on the list price column. And stats can also get created manually. They can get created manually on multiple columns, on single columns, as well as we can filter values in a column. So how to view these statistics, right? Like we have seen in our previous slides, stats can get created by using, like stats can get checked by using sys.stats view. It will give the list of all the statistics for a table, especially if you want to see a stats on a particular table in detail. You can use you can use dbcc show statistics. When you use this dbcc command, you get three different kind of information: header, density vector, and histogram. We are going to see in our demo what these information gives us. You can get just the header information by using sysdmdb stats properties, and just the histogram information by using sysdmdb stats histogram. These two queries from the last two, sysdmdb stats properties and sysdmdb stats histogram, these these you can use for the latest version of SQL Server. So this particular session is more demo driven. So let's get started with the demo. So for my demo, we are using AdventureWorks 2016 database. I mentioned big here because I used Jonathan Kahai script to import two new tables: sales order header enlarged and sales order detail enlarged. So whenever I talk about these tables, I'll just say sales order header and sales order detail table just for my easy pronunciation. Let me go ahead and put the database in the context. And let me go ahead and show you how to view the indexes on a table. sp_help index will show you the indexes on a table. So this particular, so we are mainly focusing on this particular non-clustered index. When I created this particular non-clustered index, SQL Server went ahead and create non-clustered index on the same exact column where my non-clustered index was created on. So we created non-clustered index on customer ID column. You can also view the stats by using sys.stats view. So it will give us the table name. First, it will give the primary key related stats and then all the non-clustered index related stats and then the system generated stats and the stats ID. Let me go ahead and show you the list of all the statistics and on which columns does those statistics got created, right? We can use sp_help stats to do that. When I execute that, it will give the stats name and on which column does the stats got created. We are mainly focusing on this particular statistics that got created for the non-clustered index on the customer ID column. This particular sp_help stats is deprecated, but it will give us the good information. So until they completely remove it, we can use it. So let me go ahead and show you the stats in the detail, which using dbcc show statistics. It will give the name information. The name gives the name of the statistics. When was the statistics lastly updated? How many rows we have at the time of the update? How many rows were sampled? It's 100% sample because same number of rows. And how many steps do we have for this particular stats? 153. But in max, SQL Server can have up to 201 rows for any statistics. Actually, it's 200, but that one additional step is if you have any null values in your column. We do not have any null values for our customer ID column. So there is one more column to show you if this particular stat is filtered or not. It's unfiltered, so that's the reason we have 2.4 million. When you see the density vector value, this is the density vector value of the customer ID column. Now, how does it get calculated? It's 1 divided by distinct number of rows we have for the customer ID value. This density vector will tell us how unique the column is, right? How unique number of rows we have for that column. This is this is the histogram. This is where the optimizer will go ahead and get that statistics information from. So the first column represents the columns of the customer ID. Not each and every column is represented, not each and every value is represented here. That is the reason we have range rows. Before going into range rows, let's see the equal rows. So for the customer ID value of 11,000, there are equal number of rows, 231. For the customer ID value of 11,019, we have equal number of rows, 1,309. So how many total number of rows we have in between 11,000 and 11,019 customer ID? We have total number of rows, 3,619. And distinct range rows. How many distinct values we have in between 11,000 and 11,019? It's 18. So what if I'm going ahead and searching for a customer ID value of 11,005? It is not represented in the range high key. So that is the reason we have range rows and the distinct range rows. The SQL Server will go ahead and divide 3,619 divided by distinct range rows 18, which will give you 201 rows. That's how the SQL Server will go ahead and get that statistical information from. Now we can get the same information, especially for the header and the histogram, by using systemdb stats properties and systemdb stats histogram. When I execute that, we'll get the same kind of information that we got for DBCC show statistics. Now, let's go ahead and see some examples. Let me go ahead and do a simple select on a customer ID 11,091. So when you see the histogram 11,091 is showed in our histogram, it has equal number of rows 2156. So when I execute that with actual execution plan on, when I execute that, if you observe here, the estimated number of rows 2156 and the actual number of rows are 2156. That means 100%, right? Because that particular value is unique in our histogram. But what if I search with a different value which is not presented in our histogram? When I execute that, we'll get 264, right? The estimated number of rows are 263.5 and the actual number of rows are 154. Now where is this 263 coming from? So if you see this value is not actually represented in our histogram, right? So when you see the histogram, 263 is coming from like 11,225, right? The customer ID value. It will go ahead and get that information from the average range rows, 263.5. That is where we have seen the value. So what if instead of getting the customer ID value directly, what if we use the variable? So if I declare the variable and set that variable and use the variable when I execute the query, now we get a different number. It's 127, right? The estimated number of rows is 126.7 and the actual number of rows are 2156. Now where is this 126.7 coming from? Whenever you are using any variable, SQL Server doesn't know where to get that estimates from. So it will always go ahead and get that information from the density vector value. When you see the DBCC show statistics, it will multiply the density vector value with the total number of rows, which will give you that particular 127 value. When you multiply total number of rows with density vector value, you see 126.7. That's where we got the value, right? What if instead of using the inequality, what if instead of using the equality, we use the inequality here? The same query. When I execute that, now the execution plan is completely different. Now it did a custard index scan. Now why is that? It's because if you see the estimated number of rows are 726,000, right? But the actual number of rows are 19,000. Which is way less. Now why is that? It's because if you are using any inequalities, SQL Server will get that value from 30% out of total number of rows. So when you execute that, you get that 726,000. We all use the store procedures, right? If I put the same query in the store procedure and run, sorry about that, and execute the store procedure for the first time, you get that estimate number of rows are 77 and the actual number of rows are also 77. Pretty much accurate, right? Because that particular value, this particular value is actually represented in the histogram. But what if I executed with a different value? Now, still the estimates are showing 77. The actual number of rows are 2156. Now, why is that? Because SQL Server went ahead and created the estimation execution plan for the query with a different value and it now saved inside the plan cache. So the next time you are running the store procedure with a different variable, it still use the same execution plan, right? It will not cause any problem if you don't have much skew in your data. But if you have a lot of skew in your data, then you have to make sure what kind of execution plan for which variable your execution plan is getting generated. Now, instead of using customer ID, what if I use a different person ID as a variable and then declare the customer ID and use the customer ID? What if I created that store procedure? What if I go ahead and execute that store procedure for the first time? It bought me 127, right? Now, where is this 127 coming from? If you see here, 126.7, actual number of rows are 308. Because SQL Server at the pre-optimization stage, it doesn't know what the customer ID value is. So it have to go ahead and get the estimate from the density vector value. It will multiply the density vector with the total number of rows. Now I would like to not only get the information from the sales order header, but also join that value with the sales order detail table and get the date range value of one month, and then the same query we run for the 12-month date range. What if I go ahead and run the same two queries with the different date ranges at the same time, just to show you how the execution plan looks like. Here the estimated number of rows are 4665 and the actual number of rows are 5066. That's not bad. And it did a index seek here. But when you observe here, it did a clustered index scan. It's the estimated number of rows are 105k and the actual number of rows are also 105k. But here, if you see, it did a index scan here. Previously for the 1 month date range, it did a index seek. And when you observe here, it did a hash match. That's okay for the 12-month date range. But let me go ahead and show you how to trick the optimizer by saying we just have 1 million rows instead of like 2.4 million rows, right? Just a moment. Sorry about that. So instead of like 2.4 million, how about I trick the optimizer by saying we just have 1 million rows in a table, right? I can do that by tricking the optimizer by saying we just have 1 million rows. I can do that by using update stats with a row count. Now the SQL Server is going to think there are only 1 million rows coming out of a table. Now what if I go ahead and execute the same queries for the 1 month date range and the 12-month date range one more time? If I execute that, now you'll find the difference. The estimate number of rows for the 1 month date range is 1900, but the actual number of rows are 5000. But when you see here, it's completely different. Here, the estimate number of rows are 43,000, but the actual number of rows are 105,000. It is more than half, right? Not only that, if you see here, there is an exclamation mark here. That means here it's actually spilling 1513 pages to the disk. So why is that? Why it is spilling? Because now the optimizer just thought there would be only 1 million rows coming out of a table, but in fact there are more than that rows, right? Because we have 2.4 million rows coming out of a table. So the optimizer, it doesn't like it needs more amount of memory, but it just got based upon those wrong estimates. It only got some amount of memory, and it is not sufficient, so it has to actually do spill the data to the disk. So by taking the optimizer, like I would like to show you how the wrong estimates not only affected like how many rows are coming out of, like how many rows it thinks out of coming out of a table, but it also affected by spilling out to the disk, right? Because the memory grants are low as well based upon those wrong estimates. I can clean that up immediately by running dbcc update usage, but let me put that aside for now because I am going to update in the second demo. This is my second demo. Let me go ahead and put the database in the context, and let me go ahead and update the statistics by to the original value 2.4 million by using update stats. Now let me go ahead and update the stats by default sample. How can we do that? By updating the stats with not mentioning any sample percentage. SQL Server will decide that default sample for us. So when I execute that, the update stats completed. Now if I go ahead and see dbcc show statistics, here did you see that the row sample were way too less, right, when compared with the previous one. Previously it was 100%, but now it's just 91,000. That is the default sample. SQL Server decided that for us. Now let me go ahead and show you how the SQL Server will show us the estimates with the default sample. I did not actually enable the actual plan. When I go ahead and see here, the estimates are pretty good here, right? The estimated number of rows 1100, actual number of rows 1300, and here the estimated number of rows 97, but the actual number of rows 154. That means the default sample is also working fine, but if you have so much of skew in your data, then you have to make sure like your statistics are getting updated properly by changing the percentages. Now let me go ahead and show you how the auto update stats works. But to show that, let me go ahead and turn off the stats, how it will actually affect. Like without update stats, how does it work? Now, let me go ahead and show you something here. The row modification counter. How many number of rows does we need to hit to get that stats out of date? So this is the stats that we are mainly focusing on, customer ID. This is the rows in the table and rows that we have sampled. And this is the old threshold, like for the older versions of SQL Server, before SQL Server 2016, we need to update like 485,000 rows for that particular stats to get out of date, like out of date. But for the newer threshold, which is 2016 and above, the new threshold is way too less. It is just 49,000. So let's go ahead and update. As my database is 2019, a compatibility mode, the new threshold will hit. Let's go ahead and update bunch of rows to hit that threshold and to make that stats out of date, right? Let me go ahead and update bunch of records. We are updating so much of data, so it is taking a while to run. So we have updated these many rows. When you check the row modification counter one more time, here, did you see here we have actually hit that threshold, right? Hit that threshold. But as our auto update stats is turned off, when I run a query, again, which is actually using that outdated stats, it should not update the stats. It should not update the stats because our auto update stats is disabled by default. But when it is enabled, then it have to go ahead and I did not enable the actual execution plan on by mistake. The query is getting executed. Still, it is taking a while because now the stats doesn't get updated. It is using the same old execution plan. Yes, I actually enabled it. So now, because our auto update stats didn't kicked in, even though we used a query that is actually using that outdated stats, the estimate still shows as 1800 because our stat did not get updated. But the actual number of rows are 890k, which are way too above, right? That means the stats did not get updated. Now, what if I go ahead and enable the stats, like update auto update stats to be turned on this time? Now it's enabled. So now the next time I run a query which is actually using that outdated stats, now the SQL Server should go ahead and while this query is running, SQL Server will go ahead and update the stats first, and then it will go ahead and invalidate the execution plan because now the data has changed, right? It will go ahead and create the new execution plan and update that stats information, that updated stats information to give us the results by using the new execution plan. It's taking a while to run because all these operations behind the scenes takes a while. So now the plan has completely changed, and when you see the estimated number of rows 905k and the actual number of rows are 890k, which are pretty close, right? But how do I know that the stats got really updated or not? Let me do dbcc show stats one more time. And here, if you see the updated time, it's 239, 240 here. So it just got updated, the stats. It still got updated with the default sample, but it's got updated. And let me go ahead and show you how these update stats will affect the store procedures. Let me go ahead and create a store procedure by using the same query that we executed previously, searching on the customer ID value. And let me execute the query for 10 times with the same variable. This is the execution plan we have seen. Now let me go ahead and show you the query plan inside our plan cache. Here we executed that particular query the 10 times, right? The store procedure we executed, and the plan generation number is 1. Now let me go ahead and update the bunch of data one more time to hit the threshold, 49,000 threshold, right? Let me go ahead and update. I don't know if this particular update will actually hit the threshold. So let me go ahead and show you like couple of more data. Let me go ahead and update that. Might take a while because we will update a lot of data. Let me go ahead and see if that actually hit the threshold. Results. When you see this particular stats, we have actually hit the threshold. So as our auto update stats is turned on, if I execute the store procedure with any variable the next time using the same stats, using that outdated stats, now behind the scenes, it should update the execution plan and it should create a new execution plan. Now to know whether our stats got updated or not, let's see dbcc show stats. 242, it just got updated, the stats. And if I see it in the query plan to see the change in the execution plan. Here, the plan generation number is 2 now. That means that the SQL Server went ahead and updated the stats as well as it invalidated the plan and generated new plan that we have seen here. That's how the store procedures, like the store procedures, get recompiled because of the update in the stats. That's for now in our demo. Let me go ahead and share my slides back again. So we have seen the old as well as the new threshold in our demo, right? The auto update stats will occur whenever we hit that threshold. The row modification counter have to reach the threshold. For the old version of SQL Server before 2016, it's the 20% of the rows plus 500 number of rows should be changed to hit that threshold, the old threshold, so that the stats will be out of date. And the new threshold, which is above 2016 servers, it's way too less. It is square root of 1000 times number of rows, which is way less. And this particular new threshold is very useful for the OLTP systems. And let's talk about like auto update stats asynchronously, right? This particular option is disabled by default. So whenever your auto update stats is turned on, while your stats are getting updated, we'll see a wait type in SQL Server 2019, which is wait on sync stats refresh. And if your users are waiting in line until these stats are getting updated, because now whenever a user runs a query that is actually using that outdated stats, that particular user have to wait until that stats get updated and new plan gets generated, and then use that new plan for the query that the user is sending, right? It might take a while, but usually it should not cause any problem. But if that is a problem for you, then this is an option for you, auto update stats asynchronously. If you turn this option on, you're telling SQL Server, like, even though the stats get out of date, please do not go ahead and update the stats. Once the user has been sending a query using that outdated stats, do not go ahead and update the stats right at that moment. But once the user will get the results back by using the same old outdated stats, then go ahead and update the stats later. That is what we are saying. So even though we update the stats by enabling the auto update stats on a database, it is very useful for maintaining our stats during our outage windows regularly, actually do in a maintenance window. So we can use the free tool like Ola Hellengren scripts to do that, because we have more flexibility to change the sample percentage to update these stats. There are two more options we can use while updating these stats. One is no recompute. By using the no recompute in your updated stats, you are saying to SQL Server that even though the auto update stats is enabled, please do not go ahead and update the stats behind the scenes, but just whenever I wanted to update, then update the stats by using this option. There is another option which is persist sample percent. You are telling SQL Server with this option that even though the auto update stats is turned on, do not go ahead and update the stats by default sample. Instead, use the sample that I am putting out in this particular option, right? Usually it will be 100%. So these are the two options. The second option, persist sample percent, is enabled from SQL Server 2016 SP1 CU4, 2017 SQL Server CU1, and for the later versions. So what we have discussed in this session today, we have seen what are the statistics, how to view statistics, what happens when they go wrong, and how to update these statistics. These are my references to prepare for the presentation. If you wanted to know more about the statistics, please follow these resources. I would like to thank each one of you for attending the session, for attending the Scottish Summit 2021. Thank you so much, sponsors, organizers, for giving me this wonderful opportunity to present for Scottish Summit 2021. Now, if you have any questions, please, this is the time to ask me. Thank you so much once again.